Okay, here we go. This is 1.3 measuring angles for geometry. We're going to start with some vocab here. So we got a term. An angle is two rays with a common endpoint. Endpoint. Okay, angle. Two rays with a common endpoint. All right, we can name it by its vertex. So let's draw the picture first. If I draw a nice angle here, I can name this by this vertex A. Okay, and this symbol here, just like a little angle, we can label it like that and just call this like angle A. All right, we can also name it by a number. Usually you'll see the number inside the angle. So if we have an angle 1 like that, we can refer to that by writing angle, the angle symbol, and then just putting the number there. Okay, and probably the most common way you'll see this is by its points with the vertex written in the middle. Okay, so if I'm going to draw kind of a big thing here. So here I've got two rays, and I've got point A. Do up here, we're going to do B and C. Okay, and let me cut this angle, this big angle, with another ray, which creates two other angles. Okay, so I have an angle here and an angle here. Okay, I'm going to put a point out here. I'm going to call this one D. Okay, so I could label this. I'm going to go ahead and label the large angle here by each ray and the vertex. So I'm going to call this angle. I'm talking about this large angle out here. I'm going to call this B A C. I don't know why I used a small case C. I should angle B A C. There we go. So the key here is that the vertex is in the middle. Okay? All right, so the vertex is that endpoint of the two rays. So the vertex is the endpoint, and then the two sides are two different rays, right? Like we look over here, we have AB, that's a ray, right? This endpoint is A, and then B, it goes through A, and then the other side of the angle is the ray AC. Okay, so the sides of an angle are two rays. Okay, all right, now let's move on. So now, similar to last week when we had, I think we used S and T as 2 points with the line on top versus the line or the 2 points without the line on top. One referred to a line segment and one referred to the actual measurement of the distance. All right, this is very similar here. When you have this little M here outside of the angle DOG, that's referring to the measure here. Okay, so the M stands for the measure. So here it's looking for an actual degree here. All right, whereas angle DOG is just referring to the angle. Okay, all right. Equal versus congruent, this is very similar to last week as well with line segments. Right here we have two ways to name angles. We have measure of angle A is 70. Okay, so this angle is 70 degrees. And measure of angle BCA, BCA. So because C is in the middle, we're talking about this angle here. That's the vertex. So this is 70 degrees. Okay, so we're saying here that these two measures, we could write this out as measure, or we could say angle A is equal to angle BCA. Okay, because the measures, sorry, I should put the m's in there. The measures are equal because they're the same number, right? So similar but different. If we don't know the actual degrees, but we know from right here where it says triangle ABC is isosceles, we know that these side lengths are going to be the same length, and then we also know that these two angles will be congruent. So we don't know what the actual degree is, but we do know that it is the same. Okay. Okay, last thing we'll do for today, I just want to show you guys how to use a protractor. I couldn't find a good free protractor for us to use online that is kind of like a digital version of it. So I just want to show you guys how to use it. Usually students don't struggle with this at all. And we probably won't use it a whole lot moving forward. So we're just going to kind of skip this part as far as the practice problems, but I do want to just show you guys how to use a protractor. So what you want to do is you want to take your protractor. Here's the angle I want to measure. And I just want to line up this dotted line with the bottom ray. And then I want to move this up. If you have one of these, if you don't, you can just kind of eyeball it. And if you're not sure, you can always just extend this line with a ruler and see exactly where it's at. Now, this is clearly a small angle, and we're going to get into this in a minute here. This is clearly less than 90 degrees. I think we all know a 90-degree angle looks like that. There we go. I was frozen for a second. So that's a 90-degree angle. So this is less than 90-degree angle. So I want to look at the smaller numbers here. Okay, so the numbers on the bottom. So it looks like this angle here is a little bit past, it's right in between 40 and 50. Looks like it's maybe slightly over 45. So I'm going to call that 46 degrees. All right, and this one here, this one is clearly over 90 degrees. Here's 90 degrees. There we go. Here's 90 degrees, and I'm going past that. So this is an obtuse angle, and this one looks to be, if I line up my dotted arrow on the line, this looks to be about 106, maybe 107 degrees. There we go. All right, so again, just wanted to show you guys how to do that, but we probably won't practice this a whole lot, at least right now. If I decide to change my mind, I will get you guys all a protractor, either a physical protractor, or we'll get you an online one that you can use on your computer. Okay?